since we had trouble coordinating this app. So if I had a sequence like 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, I see that I'm adding by 3 each time. And since I'm adding, this is called an arithmetic sequence. An arithmetic sequence is when you add the same thing every time, and that's called the common difference. In this case, the common difference is 3. And so what we talked about today is you could engineer a formula for any term in this sequence, even if it went on forever. And so you'd say a sub n, since this is skipping by 3, and you're adding by 3, you would use 3n. But now if I do a sub 1, a sub 2, a sub 3, a sub 1, if I fill in 1, I get 3. If I fill in 2 for n, I get 6. If I fill in 3 for n, I get 9. But I'm wanting to get 2, 5, and 8. So I realized to engineer it to be the right formula, I would use 3n and then get it to be starting in the right place. So my formula would be 3n minus 1. Then I could find like the 30th term by saying 3 times 30 minus 1. And so the 30th term must be 89, 90 minus 1. So let's see, there's another way to do it also. And so to do that, sorry, I thought that would extend my slide. I'm going to also talk about a formula. If I go 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, I realized that to get any term, I'm starting with the first term and adding the common difference a certain number of times. Like to get to the second term, I just said 2 plus 3 and got 5. To get to the third term, I have 2 plus 3 plus 3, and that gives me 8. To get to the third term, and I added that common difference 2 times. To get to the fourth term, I'm going to go to what I had, and then add 3 again. You can verify that that's 11. And so I realized to get to the fourth term, I used the first term plus 3 3s. To get to the third term, I used the first term plus 2 3s. So to get to any term, I used the first term plus n minus 1 of these differences. Like for instance, to get the 11th term, I already have the first term, so I only need n minus 1 or 10 of those common differences. And so to go up here, let's see how else we could come up with a formula. Let's see if I can erase that. I'm not sure why I can't. It has something to do with the layers, I guess. I'm going to squeeze it. Maybe I can erase this part that I just wrote. Yeah. Alright, so, or I'll just hit undo. That way you won't have all those dots on your screen. Alright, so to reiterate, I think that's good enough. Your formula is a sub n equals a sub 1 plus n minus 1 times d. So you have a choice to learn the formula for an arithmetic sequence or to just understand it with common sense. But if I use the formula, I would say any term is equal to, in this case, the first term, which is 2, plus n minus 1 times my common difference, which is 3. If I rewrite that, I have 2 plus 3n minus 3, which gives me 3n minus 1, which you notice is the same thing that we got with common sense. So you pick and choose what you want to do as you're trying your Delta Math, and we'll talk about it more in class. Just save your questions. All right, now I'm going to try to move to another slide and hope that this will follow with me. Okay, let's see if you can see this. Good. Alright, so this is working. Alright, now next thing you're going to have something called summation notation, and that's a Greek S, and it'll tell you like where to start and where to stop. I don't remember if we did this before the break. So say I have 5n, and I want you to do the first 5 terms. What this means is this actually becomes a series, because you're not just going to list them with commas, you're going to actually add them together. Like the first term is 5. This tells you where to start, and this tells you where to stop. So you're going to find the first term, the second term, the third term, the fourth term, and you're going to stop at the fifth term. So I'm going to say 5 times 1, then I'm going to say 5 times 2, 5 times 3, 5 times 4, and 5 times 5. And then I'm going to add all of this together to get my answer. So this Greek S stands for the sum of a series. A series is a list of numbers with plus signs in between them, and it actually has a single answer. It has a sum. And so our sum here, let's see, 15 plus 15 is 30, and 20 more is 50, and 25. It looks like that adds up to 75. So let's do another one. Let me see if I can get rid of this up here. Those little dots I know are going to be aggravating, so I'm just going to hit the undo button more often. I'll get used to it. Okay, so let's say if I have sigma, and you could use any letter. Let's say if I have k goes from 2 to 7 of k squared plus 2. All right, so you just follow what it says. So I'm going to fill in 2 first. So I get 2 squared is 4 plus 2. Then I'm going to fill in 3 for k, and I get 9 plus 2. Then I'm going to fill in 4 for k, and I get 16 plus 2. And we'll fill in 5 for k, and I get 25 plus 2. I'm going to fill in 6 for k, and I get 36 plus 2. And I'm going to stop at 7. We'll start at 2, filling in for k, and stop at 7. So if I fill in 7, I get 49 plus 2. So this gives me 6. This gives me 11, 18, and so on. And you add them all together for a total sum, which I'm not going to sit here and add them right now, but you can add that up. So when you use this notation, it's telling you to add up terms in a sequence or a series. All right, now let me see. Let me think what the other topic was. Let's see that you're going to encounter on Delta Math. You're going to do some arithmetic. You're going to do some sigma, and I can't remember the other thing you're going to do. Summation. Oh, recursive. Okay, which it seemed like y'all got today. So I'm going to go to another slide. Let's see. All right, and see if this will follow us to the next slide. And make sure that we can see it. All right, so we can see it. Okay, so now recursive is like if it's explicit, you have something like a formula like a sub n equals 4 plus 2n, and you can find any term like a sub 100. I could just go 4 plus 2 times 100. This is explicitly defined. If it's recursive, that means it's implied and you have to build it. You can't just jump in and find the 100th term without knowing the 99th term, and so on. So what'll happen is you'll see some like a sub things in your formula, which means you need to know terms and not just the number of the term. N stands for the number of the term. A sub n stands for the term in that spot. So I'd have to start you off like a sub 1 is 5, and then I would give you like a formula a sub n minus 1 equals, or let's say a sub n plus 1 equals a sub n plus 2. All right, so now let's find the first 5 terms. A sub 1 is 5. A sub 2, all right, let's look at this. If this is a sub 2, if n plus 1 is 2, then n is 1. And so I have a sub 2 equals a sub 1 plus 2. And now I know a sub 1 is 5. So it's sort of a chain of events called a composite function actually, and you get 7. right, so let's review this. If this is n, if this is a 1, then this is a 2. If n is 7, then n plus 1 is an 8. That means you need the 7th term and then the 8th term. Let's find the 3rd term. All right, so if n plus 1 is 3, then that means that n would have to be 2. Because if n is 2, then n plus 1 is 3. So to find the 3rd term, I need the 2nd term plus 2. So verify that this is n and this is n plus 1. All right, so now I need the 2nd term, which is 7 plus 2 is 9. Hopefully you've got the swing of it now, and to get the 4th term, you need the 3rd term plus 2 is 11. To get the 5th term, you need the 4th term plus 2, which is 13. And so there's my first 5 terms, and that's recursive. And you have only 5 to practice on Delta Math when you're doing recursive. So of course, email me if you have any questions.